Hi, and welcome everyone to the November edition of the Micro Frontends Meetup. Today, we will talk a little bit about how we can extend the thought of micro frontends from the front end, also including the backend, and what we can do with our services to get a little bit more flexible. Now, before we get into the topic, let's start with the standard bureaucratic stuff. Sorry for everyone who is already used to that, but we need to go over these points. The session is recorded and the link that you potentially currently use will remain the same. That means we will just leave the recording on YouTube. If you follow this session on LinkedIn, we also don't remove it from there. But on our official website, we will always link the stream and the recording that is available on YouTube. Now, that also means that if you ask a question, we will actually get that question live into the stream. So if you prefer some more anonymous way, then just write us on LinkedIn or use any other way or use some alias when you ask the questions on the stream. Now, talking about questions in the chat, of course, any activity in the chat is much appreciated. So thanks a lot for that. If you have any questions or some remarks, maybe a personal story, some experience you want to share with everyone, just put it in the chat. But always, of course, as a quick reminder, be gentle towards others, be open towards other opinions, and just follow rules of common life, I would say. We have a code of conduct that covers that. We never had to make use of it, and I hope that always stays the same. So therefore, yeah, your participation is really appreciated. I've already mentioned that if you have some experience to share, please do so. Of course, you can do that in the comment section, but what you can also do is just appear as a guest in the show. So this season, we didn't have many guests. We only had one, but we, of course, hope that this changes. And if you have a story to share, then just write us. I mean, we are always eager to hear your experience with micro frontends and to get to know your approach, how you tackled the problem of building up a micro frontend solution, and of course what challenges you encountered and how you solved them, and maybe what challenges remain open. So maybe someone in the community has some insights or ideas how to tackle them, right? So being a guest will only provide knowledge, not only, of course, for you, but for everyone. So therefore, yeah, we would appreciate that. I guess the easiest way to do that is to follow the link on Sessionize. That's, by the way, also available on the meetup.microfrontends.cloud website. But you don't need to follow, of course, the call for papers. You can also just write me, and then we can just align on the details that will be your appearance in the Micro Frontend Meetup. So just write me, and there we go. Last but not least, some advertisement. If you're looking for the best micro frontend discovery service, yeah, you will find it with the parallel feed service. Some people believe that the parallel feed service only works for the parallel frontend framework. That's not true. It works for any kind of micro frontend solution. So from open components to modular federation, native federation, even .NET assemblies and whatnot, you can just use this as your base for ESMs as well. So really quite flexible solution, and we will also make use of that in this talk. Rest assured, you don't need that to use any of the insights we cover here, but it will be a great tool to get started. And with that in mind, I would say let's just get right into the topic. And what I would want to do and what I would want to start with is a look at some article that I wrote a while ago, which was called Hyperscale Activated, Ship Your Own Function as a Service. Now, what's a function as a service? You potentially have heard the term beforehand. So, for instance, AWS Lambda is a function as a service provider. Other known function as a service providers are, for instance, Azure with the Azure functions, but also something like Cloudflare Workers would qualify here. At the end of the day, it's any kind of runtime that allows you to just ship pretty much code, and that then combines a code with a runtime that's already there, right? So it's not a virtual machine where you, for instance, bring a full image or even something more lightweight like running Docker images. No, this is really, the runtime is already there, which is, of course, always one of the benefits, but also one of the drawbacks, because you can't just select whatever you want. If they make a runtime upgrade, or if, I don't know, a more recent version of the framework you use is not available then as a standard runtime, you can't use it, right? So you only have to the range of selections that is provided by the respective platform. Now, what are we doing in this article? We don't need to go into details, but we will now follow these steps and essentially get behind it. So at the end, the architecture looked like this. And what we can see here is that you have one server, so an Express.js-based server, but it could be something else. We will see what that means in practice. And then this server is having communication to a Micro Frontend discovery service. Why is this communication here? Well, because this server alone wouldn't be so useful. What makes it useful is that it can actually run code that is then dynamically deployed, right? And how do we get to that information? What is dynamically deployed? This is where the Micro Frontend discovery service comes in. So we talk to the discovery service, we get the currently active Micro Frontends, and we, of course, also use here a WebSocket connection, but it could also be, of course, a webhook or something else to be notified when the active Micro Frontends change. So, for instance, when a team ships a newer version or when a Micro Frontend is disabled, we are notified in the server, and then, of course, an update cycle runs, and we just throw out, for instance, a deactivated module, or we include a new module, right? And this way, the server does never require a restart, and it will just always work with the recent version of your Micro Frontends. But now you could say these are more like microservices, but actually these are really just fragments of code, so functions as a service that are integrated. Now, how we integrate them in this demo, but you could, of course, go beyond that, is that we just create a single router in the beginning, and then for each of the modules that we include here, we introduce another router. That means we have 1 plus n routers, where n is the number of modules that we include. And so all the routing that happens inside such a module, which could be a full, let's say, Express application again, all the routing that is happening in there will also, of course, be directed to the respective module. And of course, when we disable it, we can just throw it out. But this is the great way here, because it allows us to really have a clean cut whenever we disable or when we also have an update cycle. Now, before we go into the code, let us just run it and see how that works in practice. So let me just open this, and let me also make sure, I'm currently running this, so I should stop it, otherwise we already get greeted by an error message. And so this is the Express plugins demo. This code is, by the way, also available on GitHub. You will get the link later. And I already installed the node modules. There's not many here because the package JSON is rather small. In the end, I just run it. So if everything works, great. We now started the server. It's running on the port 3000 on my machine. And then we already see that there are some modules integrated. We call them just plugins here because they are kind of server plugins. And each of these plugins is, having its own name. So we have app 1, app 2, and app 3. So we have 3 plugins. They're all integrated now in here. Great. So now with these 3 things, what we can do is we can run the server, right? So it's running at localhost 3000. So let's go in here and let's just see if that server brings back something useful. It does not, right? At the moment, it's just a hello world. And there's nothing special, of course, in the network tab here. And just keep it open just if something useful appears. But what we can do now is that we, for instance, go and call something called foo, which sits on API 1. Okay, so sorry, it's app 1. So nothing is found, but this is good because there shouldn't be anything. And if we go to app 1 foo, we now see hello from app 1 v2 foo. So what's this? So this is from the routes perspective, we have now two parts. The first part is what we would call a namespace. So this is app 1. This is by convention. You could also just, try to mix the routes, but that's always dangerous. So we namespace, and as the name of the namespace, we just use the name of the micro frontend. So if we have a micro frontend with name app1, we get a namespace app1, right? Now, what's the second part of the route? That's /foo. That was totally given now by the micro frontend. So in our case, what we have here is a very, very simple, so this is the simplest case, application that has a setup function. We call that from our main application at the end. And it gets a router. So it was just created for this one micro frontend. And what it does with the router, it sets up a new route, /foo, right? And we've seen that, and it returns something. So far so good. So this looks fine. But what's the power of this, right? So a refresh, and it's returning the same thing. So I don't know, right? So what is so cool about it? Well, the cool thing is that I can actually get a little bit, let's say, creative here. Now, I have in a Micro Frontend discovery service a so-called feed. This is a collection of modules, right, or of micro frontends if you want to. And this collection of micro frontends here, this collection may change at any time, right? So I may now upload a new version, or I may change a version. So for instance, I have different versions of this app 1 uploaded. And I could not just go back, right? Or I could go in the future. I actually don't know if those work, but let's see, because we can just try. And as you can see, it just updated, and now you have a new version qualifier here, right? So I didn't do much, but I just hit a button and I wrote back, or in this case forward, and the change is now live, right? I could also just go back, say, oh, okay, let's change this. And then the server, of course, brings back on this endpoint something else. So quite nice already, because I could now live deploy a new version. Maybe let's do this. Maybe let's see if that works. Let me call this version 202, right? I mean, we follow the same principle. And maybe we put in here something like MF Meetup. Maybe let's do it like this. I don't know, right? We can get creative here. And yeah, so now we try to deploy this. So let me open another shell here and just publish it. Because right now, I mean, we haven't done anything, right? So it's not live yet, this part. But we can make it live. So now let me go back. And log in here. Good. And if everything went correctly, we get success. Okay, this is all good. Now, the only thing missing is, are we seeing something different here? And indeed we do. So this is great, because that means it all worked, and the demo gods were not, let's say, punishing me for something that I don't know about. So publishing worked. Our Micro Frontend discovery service received the latest version of this module. It notified everyone who was interested in receiving updates. Our server, of course, was interested. And so we just update. All good. So this is quite great. And of course, there's a little bit more than app 1. There is, for instance, app 2. We could now go into all the details, what the different micro frontends do. We'll look at the code in a second. But yeah, there we just supply some query parameters. It does some computation that makes sense or not. And we return a result here, right? And of course, you could do within your module some error detection. If you detect that it's not a valid number, you might return an error code here and a different output, right? So far, so good. So this is all fine. Now, the interesting part about the second micro frontend or module here is that it's a little bit less, let's say, simple than the first one. This was just a single module. When we published this, essentially what you see here is what we publish, right? So we have exactly this thing published and it gets run and we are done here. But the second one is a little bit more complicated because there are two modules, and still this, let's say, insertion from dynamic source fully works, right? So you have here dynamic, or I mean, it's still a static input, static import, but it's dynamic in the way that, well, we need now to load from a URL that's relative to the base URL this other JS later at runtime. And even though we don't see this, because this is all happening on the server, it's not happening in the front end, right? It's happening in the Express server. It seems to work because the computation that's defined in other JS is just working. Now, we don't want to ship, let's say, the full black hole that is known as node modules, which is, in general, we don't have such a fully, let's call it, loose structure. In general, what we can do, and this is done in the third one, we might even not use JavaScript at all, or we might use something like TypeScript here, right? And here we make use of, for instance, some packages, like, for instance, cores. And for the routes that are defined in the third one, we use cores here. So in order to do that, we can then use a trick and just bundle everything. So bundling is not only useful in front-end applications, but it can also be really useful in Node.js applications. We always do that. I mean, it's also a way to guarantee that it ships in a certain configuration, and it will reduce some startup time as well, because you don't need to traverse the file system, make all the resolutions, right? Resolve the modules from no modules and whatnot. That's all done statically already in build time here. So we have a build step, and that prepares it, and when we run it, we populate the dist folder here. So that's all that we do. And so when we now talk to the third micro frontend, so let's have a look at this. I think there is just a root. You might first think that it doesn't work, but this not found looks different than the general not found, right? And the interesting part about it is that if you look at it, you get, for instance, these access control allow origin headers in here. And this is the sign that actually the middleware that we integrated from a third-party plugin, the course package, just works. So you're free to do anything, and we can just load it, right? When you can publish it, and we can load it. When we can load it, we can use it. So the final question to finish up with this demo is then, how is the server done? We now know that the micro frontends can be quite powerful, or microservices, modules, whatever you want to call them. They can be quite powerful because they can do whatever they want, except, of course, that they need to integrate into the router, and the router is inserted in such a setup function. So far so good, but the question is, of course, how does the server work? Well, the server works with plain Node.js. There are not many modules installed. Yes, sorry, this is app 3. Yes, we have some dependencies. We have, of course, Express, because it's an Express JS server. So yeah, Express is there. And the other dependency that we have is on the WS, so a WebSocket library. And we only use this to actually establish a WebSocket connection to our feed service to be notified if something changes. So other than that, there are no dependencies, and it's not a lot of code, surprisingly. And the beauty of it is that we use the experimental VM modules. That sounds like it's cutting edge, but actually it's not. You would be surprised. It's in there since, I think, at least Node 12. Maybe it was 14, maybe 10, but let's say around Node 12. So already a couple of years, and we know nothing stays longer than an experimental flag in Node.js. So it's always very, very funny to see. So why are we using this experimental flag? What is it giving us? Well, it gives us access to a lot more possibilities of the VM module. The VM module is always there, independent of this flag, but it comes with a special, let's say, set of classes like the source text module, which are only there when you have this flag enabled, right? Great. So what can we do with this? We can use this to dynamically load modules. And it's actually a quite simple and elegant process. We use to create context. So this way we can isolate also these modules. It's quite nice, right? So it will not be, I mean, you share the same runtime, even same Node.js, but you don't share anything else, which means, so you can even override what process looks like, etc. So you can really isolate up to some degree the functionality. By the way, also the Node.fs module, etc., they might not be available at all, because if you don't make this available, it's not available. So quite nice. This allows you to really sandbox these modules that are loaded. So already very powerful. Now, using this created context, we call the function link module. Okay, and link module is where the real magic is happening, because here we fetch, so using fetch already native in Node.js, we fetch the content from the URL that we received from the Micro Frontend discovery service. So this is our index.js, for instance. Then we get really the full content of it. So not just interested in the response headers, but really in this response content. And with this, we create a new source text module. It's all fine. It's awesome. This is great. And using this, all we need to do is evaluate it. So far, so good. Now the JavaScript interpreter ran over it, and we return the evaluated module. Now, during this process of evaluating it, we might encounter more imports. And this is what this callback to the link function is doing, right? Now, whenever it encounters something like, for instance, this other JS, what we do is we make a new URL and we again go over link module. This is a very simplistic way, because specifier might be something like node : fs. And so this function would need some update. And we see in the next demo how this might look a little bit more sophisticated, but not way beyond what we have here. So this is actually the heart of the whole demo here, because the thing that we really need to do is be dynamic in the evaluation. Now, all the rest really just deals now with having the routers in there and installing these kind of modules. So this, for instance, is the code to install such a what we call plugin. We create a new router using express.router. Then, of course, we receive our setup function using the load module. And then we call this function with the router that we just created for it. Finally, so we add the router to our collection of routers to find it later and properly uninstall it, right? All right, that's pretty much all we do here. When we uninstall it, we remove it from the collection of routers, and we make sure that it's not in the ensemble of currently installed plugins. And we need the currently installed plugins ensemble because presumably we get into the update scenario. And so whenever we come into the update scenario, we need to make sure to keep things that are not there for updates, to actually identify what can be just added, to also identify what can be removed, and to identify what actually needs to be removed and added again in a new version, right? And all these is, of course, kept in sync using this collection. Finally, we have two functions. Watch plugins is creating the WebSocket connection to be notified from the discovery service whenever something changes. So this just uses a little bit of WebSocket magic, nothing too unusual. The important part is whenever we see an event, so a WebSocket message that indicates that something really changed, what are we doing? Here we are doing something really drastic. And what we are doing is we are fetching the complete discovery, the complete collection of micro frontends again. So we just asked the micro frontend discovery service, hey, what modules are currently active? And so this process that's in here is pretty much the same as the initial load plugins. Just a little bit more sophisticated because, yeah, now we have to make actually the difference and to see what's the diff from the current state of the world to the previously known state of the world, right? Okay, this is where we all start. It's the load plugins. Of course, being a little bit more nicer, we would not have the watch plugins at the end here, but this is what we do. And so we have a little bit of console outputs here, but crucially, we just read out the response from the discovery service. So this gives us a good indication what's going on. Okay, but that's everything. The hello world just comes from our static route that we defined. And the final piece of this puzzle is to actually have the middleware here, that if it detects this call to namespace, then it actually just looks up if there's a router with the same name, so with this namespace, and if there is, it just hands it over to the respective router. So problem solved here, right? So we essentially just go to a sub router, and that's all there is. And with this, of course, we can now this simple way, of course, have our own function as a service container. So quite nice. A little bit of course, a little bit more details. Is this production ready? Of course not. It already starts with the scalability. Yes, we can now fully scale the development with this, but Node.js is always single-threaded, so we would need to run this multiple times, of course. And ideally, it would already utilize all the resources on one machine. So for a single machine, this also wouldn't work well. However, you could, for instance, put it in a Kubernetes cluster and duplicate the pods respectively, right? That you have multiple instances there and just always have one CPU. I think that would be great. And they all would, of course, work in sync. Or you could make a server on top of the servers, and this service dispatches now to a number of workers that's determined by the number of CPUs. You could also come up with something like this. Advantage of the latter is that only the servers or the host of these end processes would need to read out the micro frontends, and then all the workers in that server, they would just get to know what are active, and you would dispatch with this router information to them. So there could be a little bit, let's say, more resource efficient, but both ways would work to be more production ready. Of course, what you also would need to have is something like improvements to the module resolution, that you also take some of the node intrinsic modules in there, and some other things, of course, like improved logging, etc., etc. So one thing that you could, for instance, already do, and this brings us to the second demo, is replace Express with something more efficient out of the box. And what is more efficient than Express? Fastify is here one option. So we stay in the JavaScript world, and instead of having now Express, we use Fastify. So that's the same thing essentially, but just written with Fastify. Now, what are we doing with Fastify here? We create Fastify, and there's a little bit of a difference that I would also consider is good for production readiness. We have a prefix before the namespace. So instead of having just the namespace directly after the root /, you have now a certain segment, which here we call it /API, but you could call it whatever you want to. And this actually now works as the aggregator. This way, you could also mix it with some other models. For instance, it could be a general backend for frontend that also serves maybe your resources directly. So that being said, so we have here the prefix defined, and the route therefore is pretty much the same. We in Fastify need that asterisk here to catch everything that falls in there, because this is not a middleware like it was in Express. And for Fastify, there are a little bit of different rules. Express is really dynamic, which means we can create these routers at runtime and route to them. But here it's a little bit different, because the Fastify router is essentially frozen whenever Fastify finishes the startup. So once your first request hits in, Fastify freezes that, and good luck, so to speak. Now, did I close the everything beforehand? Yes, I closed it. Let me just also then close it, that I'm not getting confused. And let's try to start this demo here. Again, it works similarly. So therefore, we see similar output here. It's also integrating some plugins, right? And it's when it's all done, we should have 3 plugins, but we already get a little bit of different logging output, because Fastify comes with some batteries included, and so you get a better logger out of the box if you just say logger true, which is quite nice in my opinion. Okay, here the code is not all in one file, but actually the handling of the plugins is in the plugins folder. I already mentioned beforehand that Fastify is a little bit different. It freezes the router. So how are we handling the sub-router problem here? Well, the answer is quite simple. We create kind of our own API on top. So we don't just call setup of the modules here with a router or express router, let's say, that we created, but we actually bring in our own API. And there's a reason for that, because we don't want the microphone to know whatever prefix, etc. we decided. And also the microphone doesn't really need its own name, but still all the routes should just magically work. So we wrap all these functions like a get, a put, a post, etc., which would be on a standard router, and then we just call a real router, and then we build up whatever this handling requires dynamically. So we build up a real path that consists of a prefix, the name of the micro frontend, and then of course the path that was decided now by the author of the module. Likewise, we have maybe more options. Usually they are the second argument in the world of this router, but yeah, here we just decided let's swap the order because these options are optional. So let's disregard them. Let's make this a little bit more efficient to write. And for the handler, we use the same trick. So we have a build handler helper function here that essentially converts the handling that we have here. Well, using actually 3 parameters, request, reply, and parameters that came in to, let's say, a shape that is more known in Fastify. So the handler that you write now in your module feels kind of natural if you're coming from Fastify. So why do we need to do that? Because, again, the router is frozen. So the router that we see here is actually in the Find My Way package. So this is a package that you get already with Fastify, and Fastify uses under the hood. And we can just create a dedicated Fastify router, so to speak, and use it as a sub-router. Okay, so this is all the code here, and the rest looks very familiar because it's the same principle, right? We have all our routers, we have the ensemble of current modules, all great, all good, and also we have a watch and a load function, same old, same old. So no surprises here. Okay, so we already started it, so maybe let's have a look. Let's start with, let's go, maybe let's start here. So again, we get an immediate response when we go to the slash. We can try /API. Oh, it doesn't exist because we only have subpaths. So for instance, we have app1 and foo. And we get right instantly, so much better performance already on the local machine, response using Fastify. Now here it's the same principle, which means I can now look for the example that we have in Fastify demo. And also here we have app1 uploaded 2 times. So I can just make a rollback, can go in here, and you see it just changed. So quite nice. I can play around with it and it will just work. I could now upload a new version, it will just work, right? And this is really the beauty that you can now have this flexibility where you develop now independently, you just push there and this server takes it and makes it available. Now the same things hold true here as well. So you can call your compute with whatever values, and again, it loads your code and then of course runs the endpoint, and it's really, I mean, it's Fastify, right? So it's really fast out of the box and just works really nice and seamlessly. You could also go crazy with some dependencies. So what was decided here is that we use actually Markdown it. I haven't installed the modules in this folder, but use Markdown it in UUID. And this was done to actually have a little bit of a, let's say, document storing here. So what we could do to demo this, well, we could go to app3 and we get back that right now there is no document. Now what I could do is I could just say fetch, and I go to app3 and I use the post method, and as body I use, well, this is a good question. I think there must be a source string, but let's just try, and then if it doesn't work, I see where the problem is. And I could say hello, and then I make maybe this is a list. If I didn't mistype that, we should have a heading and then a list. You already see this is markdown. So let's see. Blocked. Okay. Should I have maybe missed a header here? Headers. And I think I might need to specify application JSON. Let's see. Oh no, it still rejects it. Let me see what is going wrong here. The post is good. Well, then it should decide the right thing, but I guess the course might be the issue here. But actually, I shouldn't get anything. No, actually, P is good. It might be that it's still cached. It sucks. I could use curl for it. Now let me also bring up Postman maybe. Let's try it with Postman. Let's do it the right way. Let's see. And allow access. Okay, let me prepare this really quick. And yeah, let's just make an untitled request. Let's see. So let's have a post. HTTP localhost 3000 API app3, and we definitely want to have a content type application JSON. Okay, so far so good. And yeah. Source. And now I need to type that in. Hello. Let me grab that and hope for the best. So something like this. I'm not sure. Okay, so now this worked better, right? Here we get an ID back. This is good because now if we go to app3, we see that this item is here, right? So great. And we, of course, we could even go a little bit further and have the ID copied. Go in here and you get this rendering, and it worked. So this is quite nice. So great success, I would say. By the way, this is only the response that you would get here if we make a request from the browser. If we make another request, let's see, then you get a JSON response here with ID, source, and an HTML code. So quite nice. It already distinguishes of the accept type that we have, and depending if we set text HTML or nothing, or application JSON, we get different responses. So great. But same principle. And likewise, we use here ESBuild to have all these dependencies really mushed together and have one output. But otherwise, it looks really straightforward. We use ESBuild, and we use the publish Micro Frontend tooling to publish the package to the Micro Frontend discovery service. Great. All right. So 2 for 2, again, same principle, and I would say even better than beforehand, because this way, yeah, I mean, you've already seen it, it just scales much better. So final thing that I wanted to show here, and also this one is available on GitHub, is that we don't need to be restricted now to having such a server. And as a matter of fact, I mean, there are certain, let's say, ideas why you might want to ditch, let's say, AWS Lambda or Azure Function for something like this, for something custom. And the main idea is that, I mean, first of all, these runtimes are not in your control. Okay, fair enough. But second of all, they come with some limitations. For instance, as an example, if you consider the viability of having a WebSocket, so a standing connection between whatever you have in your front end or another system and your functions or service provider, this will not be working, right? Because these functions are sort of to be short-lived at AWS Lambda or an Azure function, and they will not give you the ability to just, open some socket. But here you can now do that. And this is a really fun idea to play with, because you can create, using this mechanism, a server that's always there, will therefore never lose the connections that have been made, and can be still updated. Right? And that sounds a little bit like a dream, because before you had this problem. I mean, how can you update now some of the functions without having to restart the server? I mean, usually, even if you have, let's say, an Azure function, you need to update the server, and then the connections are lost, right? I mean, there are some limitations, but these limitations are now fully lifted. And so before we look at the code, we can already, let's say, start the demo. Let me show you the demo first and then discuss the code. I think I've installed everything. The package, it looks really simple here because we only use now the WS package, which of course is used to have a website connection as a client to the Micro Frontend Discovery service, but is also used now to create a WebSocket server. Now, it runs at port 3000 as well, which means just going there is not giving us anything. Upgrade required, because again, this is only a WebSocket server. You could, of course, have more in here, but the demo is really now focused on WebSockets. So therefore, imagine you can still create something like Fastify and WS, so have both demos combined and be really, really powerful. Now, so far so good. Upgrade required. So let me try to find something. Yeah, I use these few lines here now in the browser to do a couple of things. I create a new WebSocket client, and I tell the client, hey, whenever you receive a message, just print it. And we already got a message. We got a keep alive message here. So the server is already sending some things, right? So it's sending us a message, hey, the connection's still alive. This is just a broadcast that the server does with all the connections that are still there. And we get that, I think, every minute. You could, of course, change that and make it every 10 seconds or whatnot. But every minute is fine. It's good enough. All right, so what we could now do is we send something to the server. And we could send us a message like this, type foo. And the server responds. It tells us, well, there's a correlation ID. This is interesting because it associates an ID with that request. And then we get back a message, hello from app1v2. And that message, that looks familiar, right? I mean, it is the same idea from the demo point of view. Now, you might already have guessed it. There is a feed for this here. So we already got a collection of these modules. And also here, we could just swap that out. So we just swap app1 here. I don't even know. Should I maybe use something else? No, I think everything's awesome. So let's try this again. And now you see you get V1, right? So again, V1. And V2. And it is as simple as just, publishing something, or in this case, swapping something. So quite nice. By the way, the correlation ID you could also use on your own here. So I could just say ABC, and now I get back ABC. So whenever I say, hey, if you reply to my message, I want to identify that these are two things, right? That these two, my sent message and your reply, are connected. I just define what the correlation ID is. Otherwise, the server will give it a correlation ID, and I will just get back the correlation ID. Okay, so far so good. So this is all working. This is all great. And you already see where this is going. This server has, let's say, the possibility of hijacking the messages, and it's done on the basis of, let's say, an event-based system. So we receive on the entry point of the server the WebSocket message, and then it transforms this into an event. It just emits the event internally, and we can, of course, via our modules that are loaded or not, listen to those events. And when we listen to it, we can react to it. So we have kind of an API available, like send something back or use a broadcast. Now, the broadcast thing is quite interesting, because let's do the following. Let's also open another browser window. So, okay, yeah, upgrade required. So this is good. Let me pick the right one here. So this is also good. So love something like this. Okay, and now I just, connect here as well. So both are now connected, okay? I'm connected left and I'm connected right. Now what I can do is I can just send another message, and we have 3 micro frontends again. So the third micro frontend has the code that we just saw in Fastify as well. So this one has Markdown it installed and has a document database. And it has commands like list documents and get document and so on and so forth. It has a create document, and this we will use in a second. But now, first start with list documents. So now what are we doing? Yeah, I want to have both. Okay, so we go to list documents, and let me remove the correlation ID, even though in general, of course, I would insert it here because I want to know that this response with the documents is the response for this request. Okay, cool. I get back that there are no documents. Awesome, right? This one just gets to keep alive at the moment. Now, what I want to do is I want to create a document. So let me create a document. And I think this is just called source and hello, and maybe have a world in here, and then maybe first paragraph, and then maybe second. I don't know. I hope that works. Let me send it. And we created a new document. We got an event for this, and this one also got the event. So now this is really powerful, right? Because you have a mutation, but now everyone else who's connected, and of course who might have access to these resources, you can still restrict it. It's not in the demo, surely, but yeah, we just send it out. So for in this case, it's just a simple broadcast, but it's nice because here you could imagine you have a real application, and this application might be interested in whatever is happening on the server, right? And usually you do whatever, right? You use a stale while revalidate and all these things only to have a lot of overhead and all the time making requests. And here you don't need to, because actually what is the outcome? It's actually super dynamic, and it just works because we are notified whenever a new document was created. And now we could do, and let me clear this and clear that. Oh, that was maybe not so clever, because I actually wanted to delete something, so I need the ID, but okay, let's just call list documents again, and we get the documents, and there's just one in here, the one that we just created. So let me remove it. I think it's delete document, and we need to supply an ID. And again, we got it at both locations that we got document deleted. Got it here. We got it here. Here, of course, we got it because we triggered it, right? So we want to have like a confirmation anyway. But the other browser or the other users, they also receive that this document is now gone. So when they have an application that's running, that's connected to the WebSocket, these applications can also just remove it because they're always connected to it. So very, very nice, right? And now just to confirm, looking at the list of documents, we see it's empty again. So really powerful stuff, and I think really nice. So to conclude that, let's have a look at the code. We've already seen the code of the micro frontend. Now this one is using TypeScript, so it defined this kind of API, but usually we would expect, of course, this definition to come already, let's say, from a development package or SDK that we create with our server. Was not done in this demo, but definitely something I would recommend to do. And other than that, I mean, we use the same principle as beforehand. We make an instance of mark.it, and the rest is just handling stuff. Now, what is happening when we call a delete document, right? Of course, we first check something, but at the end, we use the broadcast function that's on API to return everything, right? It's quite nice. Presumably, even the correlation ID you could remove here, and that's just implicit and already transported with the API. Can think about it. Here it's quite explicit. I like that personally, because this way you can use the correlation ID also in your logs and really to have a trail and to use that also internally, right? But maybe there should be an internal and external correlation ID. I don't know. You can get crazy here also from an architecture point of view. But rest assured, if there's an error, we only send to the connection ID where we received that, and otherwise we make a broadcast, we remove it, and we make the broadcast. So how is the server looking like? Because again, also looking at the simple example, there's no magic here, right? I mean, these request response patterns look a little bit more complicated because, I mean, there are now two parts, right? So it's not just one part and we wait for the response, but it's really, if we handle, we are free what we do here. We are not forced to return something. So if you want to return something, we do it explicitly here. And of course, you could go crazy in your example and look if there was something returned. If it's a promise, you wait for it, and then you look if it's something. And if there is something, you do already what we did here automatically. You can go there, right? But if we don't go there, make it really explicit, this is what we end up with. Okay, so the server. We have the plugins, which are the same pretty much as beforehand. Just a few words in a second, because it has this link node module, and we will look at that. But other than that, we have the heart of the server is the events MJS, because this thing just has an event emitter, and that is what we use as a kind of event bus in this system, right? So everything that goes into the server will be packaged up as a kind of event, will be then messaged to the event emitter that broadcasts it to whoever is listening. And then, of course, it might be reused again to emit some other event, which is going back to the entry point and sent as another message to potentially multiple connections. We have a broadcast, for instance, that just emits a special event called broadcast. We have emit as a just export of the emit function. We have a send to function, which uses an event prefixed with to. We have an on and an off exposure that just adds an add event listener and remove event listener. So events, rather shallow abstraction, really nice. And finally, our server looks like this. We have a send keep alive function that you've seen. It just calls broadcast with this type. And this send keep alive, it's actually used with a set interval at a 60-second or 60,000 millisecond time frame. So this is great. It always sends this. And so we don't have to, let's say, start set intervals at each of these connections. When a connection comes in, it just starts listening on broadcast, and it starts listening on the to with the connection ID. Connection ID, by the way, we generate, so random UUID for it. And finally, a few abstractions over send message, and we need to define what's happening when the connection is removed. We just dispose all the handlers that we had, and so we are done, right? This is the whole WebSocket server, pretty lightweight, because all the business logic is running inside these modules. So quite nice. Finally, I already told you it looks a little bit different, because if you look at the link module, it has a little bit of logic here that wasn't there. So we look specifically if the specifier starts with a node colon string, because if it does, we want to link a node module, right? So we just make a dynamic import of the specifier, and then we return a synthetic module. I'm not sure if there's a better way to do it and to tell it, well, this is already a module. We don't need to wrap it and do all this kind of nonsense here, but I haven't found a better way. So if you know a better way, let me know. So all we do here is essentially just import again, but of course from an unknown. So that's why there's a string called specifier. Reading out what are the exports, telling the thing what the exports are, and there we go. We got a dynamically linked node module. Finally, we also specify here a context. So that we didn't do beforehand, but now we do. So we, for instance, make it possible to use console, but we also make it possible to use set timeout and set interval. If we don't do that, there is no set interval, for instance, or set timeout. And where do we use this? Because this is also an interesting thing. I think we use it at app 2, because here we compute the result, right? And you've seen it before, and it works really fast. I mean, it's just a few arithmetic functions, so nothing really that should stress the computer. But what if we want to simulate it? This is a really intense computation, right? So here we do that. We just make a computation. Then I think 2 seconds later, we return the result. And that's quite nice, because that's a huge difference now to the HTTP model, where you send something and the connection is now eagerly waiting. Will it ever return? Now with the WebSocket, you don't know, and you essentially don't care, because I mean, all you do there is send something, and maybe someone sends something back to you, but that's why you need the correlation ID to actually make the mapping. Otherwise, you never know, is this now a response to whatever I sent beforehand, or is it just a general thing that the other side wanted to tell me, right? And here, of course, you can see that is the computation. So let's maybe give this a shot. Was it compute? I don't know. Let's see. Maybe it was. Oh, it was compute. Yes. So result is minus 75, and you've seen it took now 2 seconds, right, to answer me, because we have to set timeout in there. All right, so we are already at the end. I haven't seen any questions in the chat. If there's something you want to see, something you wanted to discuss, let me know. I think this is pretty nice, because this whole model allows you to have a nice backend for front-end server that not only, let's say, ships your, let's say, essential resources that you have for your front end, right, like your main app shell, for instance, but it could also now be dynamically configured using something like this. And of course, it doesn't mean that all your crucial services are also running in the BFF. They could run on dedicated machines. But the question is now, how does the BFF know where to go for certain resources? And this way allows you to do that very nicely. Plus, of course, you don't need to have actual code. You could also just have a JSON. Same principle applies, but that code could actually be as crazy as we've seen here, that it actually has a WebSocket and makes use of the fact that the server essentially never needs to restart, unless, of course, there are some critical updates for the server, mostly security patches or something like that. In those cases, you still want to have a rolling update or some other mechanism, but rest assured, it gives you a great way to scale and to be flexible, in my opinion. And all just because you have a discovery service that you can use, and as we've seen, use also directly from Node.js with the inbuilds in there. So quite nice, quite scalable, and also, in my opinion, quite modern. Great, so that's it. We only have one more edition this year, and then there will be another break coming up for the Micro Frontend Meetup. Let's see how long we take this time and what we do with the format. In general, any feedback on that would be appreciated. And with that being said, we wish everyone a really awesome day. Keep your Micro Frontends up and running, keep them happy. And if you have any question, always just ping me. If you want to share your experience, also just write me on LinkedIn. And then we see each other on December, I think on the 12th of December. And with that, have a great evening, wherever you may roam. And have a good one. Goodbye.